We're back on the SLHF 1000 that we repaired in the prior video. And this time we're going to tackle the problem with the switch that goes bad in the front loading mechanism here. There's a little switch down here which signals by way of this connector whether you've placed a tape in for it to load. So we have to take the cassette loading mechanism out to actually work on that. How that's done is we release this little catch over here. Another little catch, I think. There we go. It just clips off there. There's a little catch right there. This cover was placed on because earlier machines, this belt had a tendency to jump off. And that's what operates the loading mechanism. So we'll take the belt off. There are 4 screws that we need to take out, if I remember. 2 down here. And 2 here. And the cassette housing should lift out. I may have to loosen the front panel off a bit just to give it some clearance. These little catches on the side here, and this should lift out. Just like that. Notice that you do not have to remove the whole front panel. Just release the screw and the little catches on the side, and the front loading mechanism lifts out. Here's the switch. We don't even have to take this thing apart. If I wanted to show you guys the workings of the gears, I'd take this apart, but because I know these gears are probably getting pretty brittle, I don't even want it to go in there at this point, because this plastic at this point is probably getting pretty brittle. I don't want to risk releasing any of the cogs here and having it break. But what I want to do is I want to clean these contacts on this little switch, because how this works, when you push a cassette in, the little cam here will close these contacts. Pretty straightforward switch, see? Zoom the camera in so you can see it a little better. So let me grab a tape. So when the tape gets pushed in, it closes those contacts. And that's what activates the tape loading. What happens is those contacts get dirty. And we're not just going to spray some cleaner on them, because spraying cleaner on them won't really do much. We have to actually clean those contacts. A couple different ways to do it. You can take the switch right out. It's easy enough to do. Just pop the little catches on either side. We can take the switch out. Now we can work on this. A nail file works really good between here. So let me go grab a nail file. Never ceases to amaze me. You know, I ask the females that live here, hey, you got an emery board or a nail file or something? They give me something that's like big enough to cut down a tree. But this probably will be okay. We can just get the contacts in here and give it a bit of a scrape. We just want to take the oxidization off the contacts, and that should do the trick. We'll just measure this with my good old meter. So beep is good when we close the contacts. Open contacts, close contacts. Open contacts, closed. So that should do the job. I have 2 of these machines to do this too. So now we can just reseat the switch again. Only goes in one way. It's actually keyed One hole is bigger than the other, and it goes in like this. Just like that. Now when the tape goes in, the contacts will close and the tape should go into the machine. So now we can reinstall the cassette basket. Again, very simple. Sometimes these sleep switches here go bad as well, the ones underneath here. They haven't acted up on this. One of these is for the cassette record detection, so that if the tab is broken it won't record. The other one is for when the cassette goes down, to tell the loading mechanism that the tape is down and it can swap modes of the solenoid. Because normally the solenoid pulls in for it to load the cassette, then it releases. And that transfers power through the power split device. I'll show you how that works too momentarily. Get the basket back in place. It just drops in place once you get it lined up. Like that. 4 screws to hold it in place. I'll tighten those ones up after I seat the back ones in. Reattach the belt. Now how this works, I'll show you this before I reattach the belt. And also on the back of this thing there's 2 sets of outputs. There's one marked monitor out and there's one marked line out. Normally what you would do is you would hook your editing monitor up to the monitor out. The line out would be connected from the playback machine to the line in of the record machine. The difference is one of them has the on-screen graphics and one does not. So when you're editing you can have your full on-screen display showing you your cut in and cut out points and so forth when you're editing 2 machines. But how this power split device works is as follows. There's one motor underneath here and it goes through a planetary power split device, and depending on which reel you lock it determines where the power gets sent. When the motor turns and the solenoid here is not engaged, the power from the motor will go through the power split device and turn this gear here. This gear here will turn the loading gears, as you can see below, to load the tape. The guides on one side to thread the tape around the drum. If I work it through by hand, if I can get my hand out of the shot here, you'll see the guides move. Guide pins pop up. They're spring loaded. You can see the guide post coming up here. The shuttle block on this side pulls the tape in place. And you can see the planetary carrier spinning underneath here. The motor drives the sun gear in the middle. The planet carrier is what turns this gear, and the ring gear is the outside case of that, which is what turns this top. So now the tape is threaded. If I want to unthread it, I just turn it the other direction. This will unthread the tape. And what happens when it gets all the way back, I'll show you how it tells the machine. I don't know if you saw what's going on here, but if we look, and I'll zoom the camera in here. How beta detects the tape is at the end, and this is important. So I'm going to move the camera directly overhead so you can see this a little better. How beta detects the tape is at the end is these little coils, these little pickup coils. What they do is, on a beta tape, and I don't have one that's rewound sitting in front of me, but It's not a clear leader like is used on a VHS or an 8mm or a DAT tape. On those tapes, those type of cassettes, there's actually a hole in the bottom of the tape and a light source is placed into the tape. The early VHS machines actually used an incandescent light bulb and they used photo transistors on either side. The more modern VHS used an infrared LED to shine a light through the tape. That's not the case on Beta. Beta actually has a metal leader. That metal leader is detected by a metal detector. So here you've got a little coil. They got an oscillation going on there. And when the metal leader passes in front of that coil, it changes the resonant frequency of that oscillator. The unit detects that the metal is there, the machine stops. That's the end sensor for when the tape gets to the end. On the other side of the machine, you've got your take-up sensor, which is right down here. So when the tape is rewinding, as the leader passes here, it tells it to stop. This detector has a secondary function. As the mechanism is unwinding, watch what happens. Okay, as I unwind it, this is their sensor right here. It's going to make contact with a little cam on this loading gear here. And as it moves back, you're going to see, oops, wrong way. Yeah, that's right way. You see it moving? There's a little lever right down here, and it moves this, and it pivots it. You see that pivoting? And when that pivots, now that coil is pointing right at this metal pin. So now it detects, again, that the coil has been brought into proximity with a different metal piece other than the cassette, because the leader has already been rewound back into the cassette. So as the leader, if it's at the beginning, is being rewound back into the cassette, now this sensor pivots and it picks up the metal post here. That signals the microprocessor that the mechanism is unwound completely. There are no optical sensors, there are no mechanical switches on these decks to tell the microprocessor when the mechanism is loaded and unloaded. And the reason for that is mechanical switches. What are mode switches? What's the biggest problem you have on a VHS machine when it does stupid things like doesn't go into the right mode? The mode switch is bad. You get noise generated on those mode switches. So Sony got rid of the mode switches. In fact, no Beta machines that have this design used a mode switch. I can't think of any Beta machines that actually use mode switches. Some of the 3/4 inch machines used mechanical switches, but most of the Beta machines that I can remember don't. They do it like this. So that tells the mechanism that it has now completely unloaded. So then what happens? This solenoid de-energizes, or no, sorry, the solenoid energizes, it pulls in. Now this solenoid here, this is the same solenoid that is used to actually engage the pinch roller. When the tape is loaded and you press play, this plunger pulls in. That is what actually pushes this pinch roller up against the capstan shaft. And I'll show you, I'll work this thing through it again in a minute to show you how this works, because it's really quite ingenious the way they did it. Anyway, now this plunger pulls in, the motor continues to turn, but now, because we've locked this other cam, this other gear, this little rocker arm's got a little catch on it. Now it's locked this gear from turning. So the power split device now forces the power to turn the top. Because a power split device, you lock one and you get power out the other. This is the same way as an automatic transmission works in your car. You know, first gear, right? And then second gear will turn another member. That's how they work on an automatic transmission. They have bands that lock the different clutches. Anyway, if we reload this thing, spend more time loading and unloading this mechanism. Now we're in position. We're in a fully loaded position. Now you'll see what happens when that same plunger goes on, it pulls the pinch roller into place. So when the plunger, I'm just looking for something to push it with. When the plunger engages, it closes the pinch roller onto the capstan. When you hit pause or stop, it releases it. It also, on the other side of the mechanism here, as you can see, it also turns on your back tension for playback, or releases it for rewind and fast forward. So now we unload the tape. Tape shuttle block and tape guides. The tape guides actually bend over. They're spring loaded. You can see. They bend over and they actually go underneath the audio control head. Now we're in the unloaded position. We can put our toothed belt for our front loading mechanism back on, and we can put the cover that prevents it from flying off, snap that back in place. We're ready for testing this machine. So once again, we have our power back on. It's ready. It's in the loaded position, ready to go. And there we go. Play. And there we go, it's working. So I just noticed something else that appears to be wrong with this. I'm gonna have to look into this. I'll check my other one out and see if it's doing the same thing. I have no video on the monitor output. If I plug my TV into my video output, I've got video, but I have no video to the monitor output. So that's throwing a wrench into this. We have to look into this and see why. Obviously my tape counter is working. You can see that it's got hours, minutes, and seconds on here. I can put this in pause and I can go right down to, oh, interesting. I saw a bit of a flash of a picture there. But I can go right into freeze frame. And the slow tracking appears to do something. Interesting. So I have to take a look at that. I seem to have a video problem going through the monitor output, the on-screen generator. I'll have to take a look at that. Anyway, you can see we can go slow 1/10, 1/5, 1 time, 2 times, and full scan, back to still, and then again in reverse. And of course, when you go into full fast forward and full rewind, well, I don't have a picture there because there's no sync. I don't have an input, but normally you would have the data screen would be there. We're gonna check this out because now I see that we got a bit of a video problem on here too. Interesting. Well, we got the cassette holder fixed. I got the power supply fixed in the prior video. What else is gonna be wrong with this thing? Hey, it's 30 years old. What do you expect? Anyway, that's how cool this is. I mean, this is all this machine. Great machines when they were new. And you got to remember, this machine is going back to 1986. I bought 2 of them when they were brand new, and I think I said before, I paid a small fortune. They were, I believe, they're about $2,500 in Canada. They were at the time they sold for about $1,800 US, but Canadian dollar back in 1986 was worth nothing. And we used to joke about it, the Canadian peso, because I think a dollar was worth about 62 cents or 63 cents US at the time. It was ridiculous. So we paid a much higher price for anything in Canada. But yeah, great machines. Now we'll dig into the video circuit and see what's going on with that. Now we know where to look. Well, kind of heading that way. We're going to need to use a scope on this one though, so stay tuned. See, now I've connected a signal source to the tuner, and you'll see that when you're in fast forward and rewind, if you've got a signal source, you get video. We'll eject the tape, now knowing that I have no overlay, even when I'm in E2E mode. I don't think I need to play a tape to find out what this problem is. We'll get the machine taken apart and we'll see what's going on with that loss of video signal going through the titler. So we're going to take the bottom off this thing so you can see the video boards. It's funny because some of the screws you don't have to even take them all the way out. Cover will slide off. You just have to take out a few of them and loosen a few of the other ones, and then the cover will just lift down. And here we have one of the video boards on this unit. And I just got to remove a couple screws, and this thing should fold down. But I just want to take a look and make sure there's nothing obvious on here. I see I just took some cobwebs off of it. Chroma. Okay, we'll swing the board down and take a look at the, oh. I'm seeing a bit of flickering video when I okay, we're gonna flip the board down and take a look at that. That's done by taking out these screws that are marked with an arrow as usual. And there should be a few on the back as well from the back panel, and that'll allow this video board to fold down. Actually, I don't even need to do that. I can just fold it down like that. Okay, so this is our video board. It's one of the video boards. This one is the Y process, and I think this is the one with the titler on it up here. This has got the inputs and outputs on it here. It's probably going to be on this board here, because the fact that the non-titled superimposed output has video. Be careful, I want to be careful around some of these encapsulated circuits, because you'd never find those today. As I continue to dig through here, I'm looking for, should be a board that has the character generator on it, and I'm looking for it. So these boards, it's kind of nice because these boards all kind of lift out of the way. This is the AU21, which is the hi-fi audio. This is another board here, IO4. I'm looking for, there should be a character generator board on this thing somewhere. And that's the one that I'm looking for, the one that puts the characters on the screen. Because I have a feeling that that is where our problem is going to be. It seems to cut in and out when at times the video cuts in and out. I get some flashes of video, but it appears to be in where the data comes through or the video comes through. I'm getting distracted because my daughter's having a meltdown outside, yelling and screaming. You can see where Sony had some running changes after production. These little daughter boards that they've put in here, they've obviously made some circuitry changes for improving the product. I'm still looking. I haven't found my character generator board yet. Somewhere in here there's a board that does the on-screen graphics. It's called a CG16 TI7. It's a tuner control board. This is the, oh, you can't see what I'm looking at here. So this is the tuner and control board here, video IF. Modulator, this is the AU board. AU21, this is the Beta Hi-Fi board. This one's a video board. No, sorry, this is the I/O board. Input output, but what the heck is this one here? Sometimes the boards have got two different names to them. They separate them in half. This is the CG16, I think. I'm pretty sure this is the character generator right in here. and I see CGFAG. So frequency adjust for the character generator. I think this is the area here. I'm just looking for the markings on the board so that I know for sure where I am. Sync AGC, I'm looking at the adjustments. Give you guys an idea what I'm working on now. I'm just going to be scoping my IC here. I've got signal going into this IC. You'll see there's video on here. I'll show you the scope. So there's video there. And this one here, this is the on-screen data. I can see it, but there's no picture. If I turn off the data screen, you'll see it goes away. See? I don't know if you can see that or not, but I can see it here. And I turn it on, and I can see the data right here, the white. Right, that's the characters. Turn the data screen off, and it's gone. See? Put it back on. So that's my output. Just looking to see where it is. This is the chip here. This is the video processor. Somewhere in this area here, I'm going to find, I'm sure, is where my problem is. I just have to, be really nice if I had a manual for this. I'm pretty sure I don't have a manual for an SLHF 1000. Thinking if I bought one or not. I might have a manual for this. If I had a manual for it, it would make it much easier to troubleshoot. I'm just going to go see if I can find a service manual, because I may have grabbed a service manual for one of these units. Well, would you look at that? Not only do I have the service manual for the SLHF 1000, I've also got the correction manual, the supplement. Following boards have been modified due to revision of the luminance and chroma processing and I/O select circuit. So, let's dig into these manuals and just chase this circuitry. Nice thing about having a full service manual is, well, I've got all the schematics, I've got the print for everything. Unlike people that think that they can work online and get all this crap online, the online manuals were just starting to come out when I got out of the business. Okay, we're going to trace this circuitry back here. Here's our monitor output plug here. The two green lines, that's for video. We got line out, which is without the on-screen graphics, and we have monitor out. And it comes off of line 25, which we follow these. This is a combination line. We follow this back. This is the direction that it goes, the double green arrows. So we're going to follow this one back, and we're going to find where number 25 takes off from this line here. So this comes back this way. And number 25, it comes all the way back here. It traces all the way back on the schematic. And 25 comes off of here. Oh, you guys probably can't see it, but 25 comes off right there. So there's a transistor here, which is the output. Obviously it's not going to be this transistor because our on-screen graphics is working, and if this transistor was bad, there'd be nothing. This is a buffer. And this transistor here is keyed from number 50 on this line. And it's going back this direction because it shows it connected here. So we're going to go back and we're going to find where number 50 comes back. And 50 comes back from here. 50 comes back from here. And if we look on here, number 50, I'm just going to try and get this thing to sit on my desk without falling over. Number 50, which is right there, is fed from IC 102, pin 21. Which is fed from IC 103, pin 4. I'm just looking for where the signals are mixed together. Comes in from pin 7. One's going to be E to E video, and the other one I think is playback video. So somewhere in here is where the signal gets mixed in. But we're going to go back. We'll go back to IC102 pin 21 and we'll see what we have there. That'll give us a starting point to see whether we've just got the on-screen data or whether there's video, and we'll work our way back. So this is where we're going to start. We're going to start here, IC102 pin 21. And that's our big IC here, IC102 pin 21. 24, 23, 22, pin 21. Looks like we've got video on pin 21. 24, 23, 22, pin 21. We have video. Do we have video with on-screen graphics? That's what I'm wondering. I think that's just straight video there. No on-screen graphics. So, yeah, we have video there. So we know that's worked. We got video but no overlay. So the overlay occurs after pin 21. That comes through a buffer transistor. And it comes up here to Q110, the next one. And that might be, I'm looking at the schematic here. Just take a look at the base and the collector of Q110. So as we've continued testing here, I appear to have lost my signal at Q108. I should have video there. That's the collector. The base going into it, as you can see, I got video going in. But on the emitter, I should have video coming out, and I don't. So I have a sneaking suspicion that this transistor here is checked out. We'll just test this transistor with doing a junction test with the meter and see. Also the voltage is low. It should be about 2.1 volts and it's like 0.7, almost like it's shorted. So we're going to power this thing down. I'm just going to test this transistor with a meter and see whether this little Q108 right here has gone bad, because I should have a video signal here on the emitter output here. I got video going on the base going in, I got nothing on the collector. So we'll get the meter in there and test it for shorts. That looks good that direction. That looks good there, but I'm getting a reading emitter to collector, which I shouldn't be getting on a transistor. Just gonna see if there's anything else in the circuit that might be loading that down. It may not be the transistor, as I'll show you the schematic here again. I'm just going through the schematic here. This transistor is actually in the blanking circuit. So what its job to do is to make the video black so that the title can be inserted so that you get a nice white character without any video leaking through. So it's basically designed to put a box around to blank the video around the characters, so that you get you can have a gray box or around the video. I'm just looking at the schematic here, and I'll show you the schematic so you can see where I'm getting to here. So we look here at Q108, the emitter, which is where I should have video. I've got video going in to the transistor. I should have video coming out the collector and continuing on its way to the right, following the green arrows that are into the next mixing transistor here. But if you also notice on the emitter, there's another line coming up here which comes through D113, which is going to be a blanking diode, which feeds in from the blanking circuit from D111 over here, and it comes all the way back to not title black, not title black, it says. On the other side of the schematic. So in theory, if I were to disconnect D113 over here, that would shut the blanking off, and I should have a picture, although no box around the video if I disconnect that diode. So maybe we'll clip that diode just to see whether we get our video back, because that'll show me what direction to go. Could be anything in this blanking circuit now and going all the way back to system control where it generates the title. But let's see where we're losing, or where our video is being muted. I'm thinking now it's not a bad transistor. Our video is being muted somewhere. It could be a broken connection for that matter. But we've got a muting problem here on the video. So here's D113 right here. Where is it? Right there. We're going to cut this diode and see what happens. So my power is off. Okay, we cut that diode. That's our blanking diode. You can see I've just clipped it and moved it out of the way. And are we gonna get a picture? Yes or no? Ah! We got a picture! And it works. I don't even know at this point whether I'm going to go any further and troubleshoot that circuit. Maybe we will, maybe we won't. I'm going to stare at the schematic a bit here and see if I can see what's going on. But yeah, now we know where the problem is. There's troubleshooting a video circuit right down to component level. So now that we've got the video circuit working, and we know it's a blanking circuit, I'm going to look down at the schematic and see if we can find out where that blanking signal, where we're getting that extra signal. It's going to be a capacitor, maybe that's shorted, or a diode, or even a transistor, somewhere in this circuit. At least we know it's in the blanking circuit, so I can trace that back and see. How the blanking circuit normally operates is it mutes the video to create that black box. Normally there's no signal. The diode down here that I clipped, wherever that diode is, right here, where am I? This diode here that I clipped, the signal comes in to that diode, and I believe it's generated in these ICs here. So we're gonna look at the schematic and see. It might even be a little capacitor like this. You know, it might even be this bad. Who knows? I'm gonna look at the circuit and just kind of go through the circuit, and we know how to create the problem. We can just reconnect the diode, and the picture goes away. So it's gonna be pretty easy to troubleshoot at this point because I know where the circuit, I know where I'm going. So let me stare at the schematic a bit more, and we'll see if we can find the component that's actually causing this, and then I can fix it correctly. When we trace the circuit back, this is the blanking line here. It comes up on pin number 3. Oh, I just stuck my finger in some old belt goop that was on my bench from a tape deck. Pin 3, title back. On CN223, this goes to the SS62 board. When I unplug this connector, my video is good. So we know that the blanking signal is there's nothing wrong with this board here. I can reconnect the diode. It's being fed in from this other schematic on page 43. So we're gonna troubleshoot it back to this one and find out where the problem is. Just so you snubby guys out there that don't believe that I'm gonna reconnect this, I've reconnected the diode. As you can see, the screen is black, and when I unplug this plug here, the screen will light up. There's the plug undone. Okay, so we're going to trace it back and see where the problem lies, and find out. We're going to trace it back to the other board. So basically our signal is just passing through here. It comes up here. Where is it? Title black right here, pin number 3. It says it meets up with 92. 92 traces its way all the way back across here, all the way across the other edge of the page. 92 comes out. It's over here somewhere. Where did 92 come out? Right here. So now we're going back to page 53 of the schematic. So we're going to yet another board. And that's what's nice when you've got paper schematics, is that you can lay these all out. Can you imagine the headaches trying to trace this through on a computer screen, looking at small little bits of it at a time and having to page back and forth? It's awful to try and work on something off PDFs. It is just god awful. Nothing beats a paper schematic. So we're going to go to page 53 now, and it's on connector, system control block, and what connector is that? It says page 53. Title back, not title back. It's got the line over it. System control block, page 53. 51, 52, 53 is here. System control block, not title back. Where is it? Here, somewhere in here we will find that input. How about I pull the whole thing? Page 53. Here we go. Here it is here. You guys can't see it, of course. It's right here. It comes off this pin here, and it comes back to, goes back to page 46. What the hell? It's going back on another connector here to servo block. we're chasing things back and forth. Back to page 46 on the servo. Make sure I'm on the right one here. System control, page 53. And now we got to go back to page 46, which we're back here. What the hell? And it comes back again. This is see page 46. See page 46. See page 72. Okay, so now it's come in here. Where did I see it? It's come in here. And it's going back out here. Where did I see? Page 72. Pin 7. Yeah. It's going out on CN 801, pin 7 to page 72. So all I do is go through pages. 72, pin 7. 72. Here we go. Black screen, off on. Is there a freaking switch on this stupid thing for that? I feel like a fucking idiot. Dope! This is one of these Homer Simpson moments where I can say dope. There's a switch on the front that you can use to create a black screen for recording. Now remember, for recording a tape with control track and no video. You can mute the video, create a black screen for making a black tape. Dope! What a... see, that's what happens when you don't use these things for 30 years. Thanks for watching, guys. I feel kind of silly now after spending the last hour chasing electrons. At least you learned something about how to troubleshoot electrons and how to find where faults are, even when there's something as ridiculous as a switch in the wrong mode. Well, yeah, I kind of feel silly about that because, as I say, I just wasted a whole bunch of time chasing a problem that didn't even exist. Little switch behind a door on the front that I had if I had paid attention to it. But again, as I said, I haven't used this machine for 30 or so years. But at least you guys got to see the inside of an SL1000, SLHF 1000, one of the finest beta machines Sony has ever made. And we're one step closer now for the next video that I'm going to do. And that video we're going to hook the two machines together and actually proceed to edit a little tape. I have to make it a special occasion. I'm going to have to come up with some video that we can record. Go get some camera footage or something and dub it down to standard definition so that we've got something on a beta tape that we can assemble together, so you can see how nice these machines worked in the day. It was really nothing else really on the market that worked like these ones did. At least it's going to go back together pretty quick here. Just a few screws and the cover will go back on. The board's in place, the other board's already been attached. I've got a couple screws, a couple black screws to go in the back here. Now we get the bottom cover on now. There we go. Back together at last. Power on. Picture. Playback. And there we go. Oh, there we got here tracking. There we go. As you can see, it's not time code, but it's close enough. frame accurate. Hope you enjoyed this video. The next time you see an SLHF 1000, there'll be 2 of them sitting stacked with a couple monitors, and we'll be putting a tape together. And I look forward to doing that in the not too distant future. Bye for now. Got all of these machines, they just look and operate so cool.